Hi guys, so today we are going to be building on what we learned yesterday about combinations and the different you can get. So we talked about yesterday the different ways that you can organize your outcomes, either that be through lists, tree diagrams, or tables. Our warm-up today starts with two friends at a restaurant each order a fruit drink. The available flavors are peach, orange, or mango. Write an organized list using the format friend 1, then friend 2 to represent the sample space of the friend's fruit drinks. So this is wanting an organized list, and I'm just going to start with the first option because that just helps me and how I'm organized. So I'm going to start with peach first for friend 1. Then friend 2 could get the option of orange. That's one way. Another way, starting with peach for friend 1, would be peach mango. And since it didn't say that they had to have different ones, you could also do peach for both friends. And that gives you all those options. Now let's start with friend 1, start getting orange. You do orange peach, orange mango, and then orange orange. And then now, last but not least, start with mango for friend 1, mango peach, mango for friend 1, orange for friend 2, and last but not least, mango for both of them. So all together, there are 6 different outcomes. All right, so today we're building on that, and we are going to be talking about a little bit faster way to do this instead of making all the different organized lists. And it is called the counting principle. So this principle, if there are M possible outcomes of one action and N possible outcomes of a second action, then there are M times N outcomes of the first action followed by the second action. So I know that was a bunch of gibberish to you guys, so let me help you help in explaining that a little bit further. So we have 2 steps here. In the first step, you choose one shape. There are 2 different outcomes that you could do. You have 2 options to choose from. So you have 2 for the first step. And then for the second step, you need to choose one color, orange, purple, or green. And that's 3 different outcomes from there. So that's kind of your second step. Using the counting principle rule, we can do 2 times 3 to get 6 different outcomes. Or if we didn't know the counting principle, we could make that tree and we could count that there's 1, 2, 3, 4, 5, 6 different outcomes. So let's go ahead and try some examples on our own using the counting principle. Then we're going to check your results by writing out the sample space for the election. So here we go. We got a ballot for class elections. So you have 2 options for the president. You have 3 options for the secretary, and then 2 options for the treasurer. So using the counting principle, we need to see how many different ways could someone fill out this ballot. So using the counting principle, how many options? You either pick, this is your first option, you pick a president, then you pick your secretary, and then last but not least, you pick your treasurer. How many options or outcomes do you have for the president? Well, we have Marta and Ethan. That's 2. So you can do 2 times because that is the counting principle. Secretary, you have Ben, Rosa, and Zach. That's 3 different outcomes. And then last but not least, you have 2 people to choose from for treasurer, Andy and Theo. So using that counting principle, we can do 2 times 3, which is 6, times 2 to get 12. Whoa, it's a funky 12. 12 different outcomes. Using the same thing, we're going to be doing this all day, using the counting principle. At Charlie's House of Chili, your chili can be mild, medium, spicy, hot, or super hot. You can have it with or without cheese. How many different ways can you order chili at Charlie's House of Chili? So this one's a little confusing because you need to ask yourself, how many steps are there? And then once you ask yourself that, make your little lines to represent those steps. So the first step, you need to pick how hot you want it. Then your second step is, do you want cheese or no cheese? So for your first step, for your level of spicy, you have 1, 2, 3, 4, 5 options. So 5 different outcomes. From there, you can have it with, so that's one option, or without, that's another option. So you have 2 possible outcomes from there. And using the counting principle, all you have to do is multiply those 2 numbers to get your answer of 10 different ways you can order a chili. If you don't believe this, you can make a tree, you can make an organized list, but I promise you this counting principle is way easier. So a lot of times you guys always ask me, well, when am I ever going to use this in real life? Well, think about how many different outcomes you can do at Chipotle. So you got to choose from your rice first. Well, there's brown rice, there's white rice. So that's 2 different outcomes right there. From there, you have to pick your type of beans. Then you got to pick your type of meat. There's like 5 different meats. So think about all the different combinations that you can do at Chipotle that all the business owners have to think about so they have enough supplies. But I'll bear you some time and I won't go through all those combinations with you. So kind of the second part of today, given the sample space of an action, you can identify outcomes that have particular characteristics. These outcomes compose an event in the sample space. So I'm going to be giving you sample spaces and you need to be able to pick out what matches the criteria. So for example, toss a coin and roll a standard number cube. This is the sample space right here. Those were all the possible outcomes from that event. I want to know when you tossed a coin or tossed tails or roll an odd number. So it doesn't mean that you have to have tails every single time, and it doesn't mean that you have to have an odd number every single time. So out of that sample space, there was 9 outcomes in that event. So we're going to build on this a little bit more in the next example. So we're going to be using a tree diagram that shows all the possible ways boys and girls can be born into a family with 3 children. Complete the table. So we made this yesterday in class, but today we want to know the event of exactly 2 boys. So the outcomes in this event, we're going to make a little list when it occurred that exactly 2 boys. So if I start with boys up here, I can travel and go up. That's exactly 2 right there. So that means that I have to go to the girl. So that's 1. So I'm going to go B, B, G. That's 1. Now let's start. I'm going to have to go down because I can't do B, B, B. So I go B, G, B. It's a terrible tree. And then I can't get any more up there.